force of friction. You must have experienced that your bicycle slows down when you apply the brakes, or a moving ball on the ground stops after some time. What may be the reason? This is due to the force of friction. Let us understand the force of friction by performing a simple activity. Gently push a book on the table. It stops after moving some distance. Now push the book from the opposite direction. This indicates that there must be a force acting on the book, opposing its motion. This force is called force of friction. Hence, we conclude that friction opposes relative motion between the surface of the book and the table. But the force of friction is not same for all surfaces. Let us find out. Take a spring balance and a brick tied with a string around it, as shown. The spring balance consists of a coiled spring, which gets stretched when a force is applied on it. The stretching of spring is measured by a pointer moving on a graduated scale. This reading on the scale gives the magnitude of force. Now pull the brick by a spring balance. When the brick just begins to move, note down the reading on the spring balance. It gives you the measure of force of friction between the surface of the brick and the table. Repeat the same activity by wrapping the brick with polythene. Note down the reading. Then, wrap a jute bag around the brick, and repeat the same procedure. You will observe that the brick, when wrapped in polythene, gives minimum reading on the spring balance, due to the smooth surface of polythene. This indicates that the force of friction depends on smoothness of the surface. Note that the friction can never be entirely eliminated, as no surface is perfectly smooth. Some irregularities are always there,